Hello, welcome back to our channel. In our last video, we explored the concept of gravity. In this video, we will look at the fascinating phenomena caused by gravity. Some of the most well-known effects of gravity include weight, atmospheric pressure, tides, and gravitational lensing, which allows scientists to observe distant parts of the universe. Let's start by talking about weight. Many of you probably go on a diet every year because of your weight, right? But did you know that weight exists because of gravity? Our bodies are made up of numerous substances. At the molecular level, most of our body consists of water, followed by proteins, fats, and minerals. If we break these molecules down further into atomic particles, our body is primarily composed of oxygen, carbon, hydrogen, and nitrogen. Each of these particles has its own inherent mass. Regardless of whether we are on Earth, the Moon, or in space, the total mass of our body remains unchanged. Weight, which we often refer to in daily life, is a measure of how much gravitational force is acting on an object with mass. Since weight depends on the gravitational force applied to an object, it varies based on location. For example, an object that weighs 100 kilograms on Earth would weigh only 17 kilograms on the Moon, where gravity is just 17% of Earth's gravity. In a zero-gravity environment like space, weight cannot be measured at all. Another phenomenon caused by gravity is atmospheric pressure, which we often hear about in weather forecasts. Unlike the Moon, Earth has an atmosphere. This is because Earth's gravity is 6 times stronger than that of the Moon. During the formation of Earth and the Moon, larger particles near Earth were unable to escape its gravitational pull, leading to the formation of an atmosphere. However, since the Moon's gravity is only 17% of Earth's, it lacked the strength to hold onto surrounding particles, causing them to drift into space. This is why the Moon has no atmosphere. Earth's atmosphere extends approximately 1,000 kilometers above the surface. The force exerted by atmospheric particles trapped by Earth's gravity is what we call atmospheric pressure. Now, let's see how atmospheric pressure is related to gravity. In our previous video, we explained that gravity is the force that pulls objects with mass toward one another. This principle also applies to the molecules in the atmosphere, such as nitrogen, oxygen, and carbon dioxide. Therefore, the molecules in the atmosphere also have a small weight due to the Earth's gravity. The force that the weight of the atmosphere exerts on the surface of the Earth is called atmospheric pressure. We will explain atmospheric pressure using the 4 layers of the atmosphere and the surface of the Earth. When a ball that was not affected by the atmosphere falls down, the weight of the atmosphere, that is, the atmospheric pressure, increases and it is compressed. Due to this characteristic, atmospheric pressure varies with altitude. At lower altitudes, more air molecules press down, resulting in higher atmospheric pressure. As altitude increases, fewer molecules are pressing from above, causing atmospheric pressure to decrease. Now, let's talk about tides. How does gravity affect the rise and fall of ocean tides? Tides, also known as tidal variations, occur due to the gravitational forces between the Earth, Moon, and Sun. If we consider the gravitational force between the Earth and the Moon as 1, then the gravitational force between the Earth and the Sun is approximately 0.5. This comparison helps us understand just how massive the Sun is. The gravitational pulls of the Moon and the Sun cause the sea level to rise and fall, creating high and low tides. Depending on the positions of the Earth, Moon, and Sun, the difference between high and low tides varies. When the Earth, Moon, and Sun form a 90-degree angle, their gravitational forces pull in different directions, resulting in the smallest difference between high and low tides. On the other hand, when the Earth, Moon, and Sun are aligned, their gravitational forces combine, causing the greatest difference between high and low tides. Similarly, when the Sun and Moon are on opposite sides of the Earth, the gravitational pull from both directions causes a significant difference between high and low tides. The next video will show a simulation of how the difference between high and low tides changes over the course of a month, depending on the positions of the Moon and Sun. Although we don't directly feel the gravitational forces of the Moon and Sun, they are constantly affecting Earth, which is quite fascinating. Now, let's talk about gravitational lensing. Do you know what astronomers are most eager to observe? It's the light from the early universe, the light that existed when the universe first formed. However, there's a problem for this light to reach Earth. It must travel an incredibly vast distance. Because light travels in a straight line, if an object is in its path, it becomes impossible to observe. Therefore, it is nearly impossible for light from the early universe to reach Earth without interference. However, gravitational lensing provides a way to overcome this challenge. Strong gravitational forces can warp the space around them, bending light in the process. For example, when light passes near a massive celestial body, like a black hole, its path is curved due to the object's intense gravity. Gravitational lensing takes advantage of this phenomenon by bending light. It allows us to observe distant parts of the universe that would otherwise be hidden from view. By altering the path of light, even celestial objects that were previously unobservable can become visible. This effect, which enables us to see parts of the universe that were previously beyond our reach, is known as the gravitational lensing effect. The following image is a simulation of how light behaves when passing near a black hole. You can see how the path of light drastically changes around the black hole. By utilizing this effect, we can observe light from even farther away in the universe. In this video, we explored some of the fascinating phenomena caused by gravity, including weight, atmospheric pressure, and gravitational lensing. We learned that weight is the force exerted on an object due to gravity, and atmospheric pressure is the force exerted by Earth's atmosphere as it is pulled down by gravity. Finally, we discovered that gravitational lensing not only affects physical objects but also bends light, allowing us to see deeper into the universe. This reminds us once again that natural phenomena are interconnected and influence one another. Thank you for watching until the end. My weight exists because of gravity.